This is the topic number 1 review video. So question number 1 gave you 5 numbers and asked you to place them on this chart. So remember, the boldface R is for real numbers, so that's anything that's not imaginary. The boldface Q is for rational numbers, so anything that can be written as a fraction, terminating decimals, or repeating decimals. The boldface Z is for integers, so anything that is not a fraction, negative, positive, or 0. And then boldface N is for natural numbers, so positive and 0 integers. So pi is a real number. That's as far as it can go because its decimal is never repeating and never ending. Sine of 30 degrees is the same thing as 1/2 if you'd plug that in your calculator, so it's rational. And same with 0.02 because it's a terminating decimal. -2 is a integer, and 0 and 12 are natural numbers. This question is from the beginning of chapter 2. Number 2 tells you that to calculate 77.2 times 3 cubed divided by 3.6 times 2 squared. So if you plug that in your calculator, make sure you're very careful to put parentheses around the numerator and around the denominator. And you end up with 144.75. If you round that to 3 significant figures, it'd be 145. Part B wants you to write that in standard form or scientific notation, so you end up with 1.45 times 10 to the 2. Part C is kind of a different question. It says that Juan estimates the length of a carpet to be 12 meters and the width to be 8. He then estimates the area of the carpet, so part I wants you to estimate that. 12 times 8, because it's rectangular, is 96. And then part II says that the actual area is 90 and to find the percent error. So percent error is actual minus estimated divided by actual, absolute value of that, times 100%. So you end up with 6 2/3 basically. If you round to 3 significant figures, it'd be 6.67%. This question is also from the beginning of chapter 2. Question number 3 is from chapter 2 again, so we're talking about linear systems. So they tell us about some prices of loaves of bread and milk. So they give us this first equation that 8 loaves of bread plus 5 liters of milk is 2140. So they give us this 8b plus 5m equals 2140. And then part A wants us to write an equation on the other day's sales, which was 6 loaves of bread and 9 liters of milk for 2340. So 6 times the price of bread plus 9 times the price of milk was 2340. So you end up with 6b plus 9m equals 2340. And then part B wants us to solve this. So I used elimination. I multiplied the top equation by a -3. And I multiplied the bottom equation by a +4 in order to cancel out the b's. So multiplying the top equation by a -3, you get -24b minus 15m equals -64.2. Multiplying the second equation by 4, you get 24b plus 36m equals 93.6. So then you add the two equations together, the b's cancel out, you end up with 21m is equal to 29.4. Divide both sides by 21, you end up that milk costs $1.40 per liter. Then take this, plug it into either equation, and solve for b. I plugged it into the top equation for m, so you get 8b plus 5 times 1.4 equals 21.4. 5 times 1.4 is 7, so subtract 7 from both sides. 8b equals 14.4. Divide both sides by 8, you get that the price of a loaf of bread is $1.80. Question number 4 is also from chapter 2, the end of it, talking about quadratics. So they give us some points about a quadratic equation. They tell us that it intersects the y-axis at the point 0,5, it intercepts the x-axis at the point 1,0, and it has a vertex at 2, -3. And they want to know where it intersects the x-axis again. So we know that all quadratics have this axis of symmetry down the middle. So whatever happens on one side of the parabola is happening also on the other side. So if there's this point here at 1,0, reflected across this axis of symmetry that's in line with its vertex, there's another x-intercept. So if there's a 1 at 1,0, that's one distance, one spot away from the axis of symmetry, one spot away on the other side at 3,0, it's also going to intersect the x-axis. So the other x value is x equals 3. Number 5 is a Chapter 7 question, Arithmetic Sequence and Series. So they give us this arithmetic series that Jasmine collects stamps. She starts with 7 the first month, and then 11 the second month, and then 15, and it continues to increase by 4 every time. We know it's arithmetic because they're adding the same thing every time. So the general formula for this series, the sequence, would be u sub n is equal to 7 plus 4 times n minus 1. First term plus the common difference times n minus 1. So for part A, they want to know how many stamps she collected in the 12th month. So that's the sequence formula. So plug in 12 for n and you end up with she collected 51 stamps that 12th month. Part B wants to know how many total stamps she collected in the first 24 months. So total, that is summation. So you're going to use your sum formula for arithmetic series. In this case, we don't know what u sub 24 is. So I use the one where it's 2 times the first term plus the common difference times n minus 1 and n divided by 2 in front, where n is 24. And you end up with 1,272 stamps. You could have also done it on the graphing calculator, math 0, which is sum, x equals 1 at the bottom, 24 at the top of your summation, and then the explicit formula inside. Part C wants to know what month she's going to exceed 500 stamps. So that's the total number of stamps. So that would be your arithmetic series, and she wants that to be more than 500. We don't know what n is. That's what we're trying to solve. So I took this same formula from part B, and I just left n to be n, and I put that in as y1 in my graphing calculator, and I put 500 as y2 in my graphing calculator, and then under y equals, and then fix your window so you can see everything. Second, trace 5 is intersect. Find your intersection point. You find that n is 14.6, but you can't have a fraction of a month in this case, so it would be the 15th month. Question number 6 is another Chapter 7 problem with geometric sequence and series this time. So they tell us that Martha is putting money into an account, a savings account for her son, and every birthday she deposits money into the account. So the first birthday she puts in 120 euros, on the second one 126 euros, and on the third 132.30 euros. For part A, we want to explain why the common ratio is 1.06. So for common ratios, you can always take a term and divide it by the term right before it, and that's how you get the common ratio. So 126 divided by 120, or you could have done 132.3 divided by 126. Either way, you would end up with 1.05. So she's increasing the amount she deposits by 5% every year. Part B wants to know how much money she will deposit on his 5th birthday and on his 10th birthday. So since it's on that specific birthday, that's going to be the explicit formula. So in this case, u sub n is equal to the first term, 120, times the common ratio, 1.05, to the n minus 1. So for the 5th one, plug in 5 for n, you end up with she's going to deposit 145.86 euros. They tell us to round to 2 decimal places because it's money. On the 10th birthday, she will deposit 186.16 euros. Part C wants to know at the end of the 10 years how much total money will he have in the account, and so that's summation. So your geometric sum formula is your first term times 1 minus your common ratio raised to the nth power divided by 1 minus your common ratio. If you plug in all your information, plug in 10 for n, you end up with 1,509.35 euros. You could have also done math sum and used your sum formula to get the same answer for part C. Question 7 is a mixture between Chapter 7 with the arithmetic and geometric sequences and Chapter 8 with the compounded interest. So Varag is getting an allowance for her 18th birthday, and she was given 4 choices. So part A wants us to find how much money she will have at the end of the year, depending on which choice she picks. So for option A, she just gets $100 a month for 12 months, so 12 times 100 would just be 1,200. Option B is a compound interest, so remember this is on your formula booklet. So her future value is equal to her present value of 1,100 times 1 plus the interest rate, which they say is 12%, divided by 100 times how many times a year it's compounded. It's compounded monthly, so that would be 12. Raised to the times of year it's compounded times how many years, so 12 times 1. So she would end up with $1,239.51 at the end of the year. Part C, or option C, is arithmetic. It's $75 on the first month and then an extra $5 more every month. So I use the arithmetic sum formula, n divided by 2, where n is 12, 2 times the first term, which is 75, plus the common difference of 5, times n of 12 minus 1, and you end up with $1,230. You could have also done the math zero sum on this. And then option D is geometric, with the first term being 80 and the common ratio being 1.05, since it's increasing by 5%. So sum formula for geometric series, first term, which is 80, times 1 minus the common ratio of 1.05 raised to the nth, which is 12 power, over 1 minus the common ratio, you end up with $1,273.37. Part B asks which option she should choose. So given these 4 answers, she should choose option D because it ends up with the most money at the end of the year. Part C says that at the end of that 1 year, she's going to deposit $1,200 into another account, and in 2 years, on her 21st birthday, she wants to buy a scooter that costs $1,452. So how much compounding once a year does this interest rate have to be in order to achieve that? So we have the future value of $1,452 is equal to the present value of $1,200 times 1 plus your rate, which we don't know, over 100 times 1 because it's compounded annually just once, raised to the how many years of 2 times how many times a year it's compounded, which is 1. So you could solve this just algebraically, or you could use the financial app on your graphing calculator. You could have done that up here for option B as well. So you go to apps. Number 1 is finance. Number 1 is TVM solver. So N would be 2 because it's 2 years. I, we don't know yet, so you just ignore it for now. Present value would be negative $1,200. Payment is 0. They're not adding any extra payment to it. Future value would be $1,452. Payments per year you can leave at 1. Compounded per year would be 1 because it's compounded annually. So then go up and highlight I, what the interest rate, and hit alpha enter, and you end up with an interest rate of 10%. The last problem, number 8, is from Chapter 8, the exchanging of currencies. So they tell us that Frederique is traveling from Canada to Moscow, and she wants to change 800 Canadian dollars into rubles, Russian rubles, and the exchange rate is 1 Canadian dollar is 29.7044 Russian rubles. So part A asks how many rubles she receives. So if you do some dimensional analysis, 800 Canadian dollars, and then you want to make sure you cancel Canadian dollars, so 1 Canadian dollar is going to be in the denominator, and 29.7044 Russian rubles is going to be in the numerator. Canadian dollars cancel, multiply across, she's going to end up with 23,763.52 rubles. Part B wants to know if she has 7,000 rubles left at the end of the trip, and she wants to change those back into Canadian dollars. Assuming the exchange rate hasn't changed, how many Canadian dollars she'll end up with. So on this one, we want to flip it because we want rubles in the denominator. So 1 Canadian dollar is 29.7044 Russian rubles. So the rubles cancel, divide 7,000 by 29.7044, and you end up with 235.66 Canadian dollars. So this has been the review video for the Topic 1 test. Remember, it covers Chapter 2, Chapter 7, and Chapter 8.